Okay. Here is the general form of the binary equation. Is dy by dx is equal to qxy. I'm sorry, dy by dx plus pxy equal to qx times y to the power n, where n is any number, but n should be equal to 0 and n should be equal to 1. The reason why n can be 0 and can be 1 is just because of that. If n is equal to 0, then y to the power n is equal to 1. Then this equation becoming to a linear differential equation, so you don't need to use the binary equation to find the solution. But if n is equal to 1, you would get y here, right? Y to the power 1 is a y. You have yz. You put this term together. This equation becomes a separable equation. So that's why you don't need to use binary equation to find the solution. But other thing else, n could be any number, can be fraction, can be integer, can be minus, can be the negative value. So if you arrange your differential equation, don't forget, okay, in front of the term of dy by dx should be 1. Because to make it to be 1, the coefficient in front of dy by dx has to be 1. Then you would know what is exactly the number of n. Okay. So if you arrange the differential equation and then you find out that your differential equation is in the binary equation form, then the way to find the solution is just that. First, you've got to assume 3 is equal to y to the power of 1 minus n. Let me put this one as the equation 1, and let me put this one as equation 2. 2, you do differential of v by m. You do differential of equation 2 by m. You would get dv by dx is equal to 1 minus n y to the power 1 minus n minus 1 dy by dx, or 1 minus n y to the power of minus n dy by dx. You do rearrange this equation in such a way that dy by dx is a function of dv by dx. So you would get dy by dx is equal to 1 over 1 minus n times y to the power n dv by dx. That is equation 3. The third step is just that you plus equation 3 into equation 1. So you would get 1 over 1 minus n y to the power n dv by dx plus pxy equal to qx times y to the power n. And then you make the coefficient in front of dv by dx equal to 1. Okay. you would get dv by dx plus px times 1 minus n times y to the power 1 minus n equal to qx times 1 minus n. Right? Because y to the power n and y to the power n cancelled out. This is equation 4. And then you plug equation 2 into 4. Equation 2 saying that v is equal to y to the power 1 minus n. We have y to the power of 1 minus n there. Just change this to dv. You would get dv by dx plus px times 1 minus n times v equal to 1 minus n times qx. This is equal equation 5. If you take a look at equation 5, you would know that you have linear differential equation, right? Equation 5 is in the form of linear differential equation. So we would use the technique of finding the solution for linear differential equation to find solution. And then you would get v is a function of v and x. And then using equation 2, which is v is equal to y to the 1 minus n, to change the v in your solution back into y. You would get y is the function of xy, and then that would be the answer. Right? From linear differential equation technique, you would get v as a function of vx, right? Because this is in the form of linear, right? And then you just finding the integrating factor. But now your px is not px, it's become 1 minus n times px. And your qx is not qx, it's becoming 1 minus n times qx. Just that. Here.